So good evening, everybody. I have to thank Dr. Shantaji and Dr. Muniji for calling me again here this time. Can I have my presentation? So, I have been tasked with speaking about the organic heart and the difference between plastic heart and organic heart. As you all know, as we enter in this era of cyborgs, many organs are getting replaced with artificial organs, and heart is no exception. And so, but the moot point is whether we can really replace heart in our body with something plastic which can take over its function or not, and that's what I'm tasked to speak upon. Now, if you look at the difference between the plastic and organic, is really the difference between physics, chemistry, and biology. So, for example, we know that in all living systems that are there is an organization of matter, in this case the heart cells or heart muscles, with energy, which is the movement of the heart, organized by informatics. So I think this is the key to all living systems, that there is a matter which uses energy to do its work, organized by some central informatics. So this thing also holds true for heart, and we will see how it really operates. This idea about reduction of heart as a machine was, as a matter of fact, first proposed by Leonardo da Vinci himself in 15th century, where he thought that heart could be explained in terms of a mathematical model, and he thought that geometry was a complete explanation of how heart works. And so if you could understand geometry, you could actually understand not only the function of heart, but you could use it to create a new artificial heart. And as a matter of fact, he said that somebody who doesn't know any mathematics may not read my principles at all. So he thought that this biology of heart could be reduced to science of mathematics. So let us see. But the point is, why do we keep thinking of replacing organic heart with a plastic heart? Why should we be at least concerned with that? The reason and why I say so is because that heart is an incredibly reliable organ which never pauses, and I just discussed this a bit earlier. There are only three systems in the body which are automatic, which could keep functioning or keep moving all the time. One is respiration, which you can voluntarily hold on for some time, but you cannot hold on indefinitely. You have to go back, but you could at least temporarily stop it. Heart is another organ which is automatic, which keeps beating. There may be some situations where in between there could be cardiac arrest and heart could stop, but only for a few minutes. Within few minutes, 30 seconds, 1 minute, if you cannot revive heart, the person may die. And the third system is the movement of brain waves, and even if the person is deeply anesthetized, some movement of brain waves are there, and if it becomes flat, we call it brain dead, and then that is perhaps the end of the life. So there are three automatic systems in the body, and all three are essential for life, and I think they are the essence for any living system. So heart, being one of the very reliable system, actually it beats faster than respiration, so it is the fastest moving organ in the body, and it never pauses. It gives the correct output all the time, and it responds to variety of signals, one of them from brain, but also from other signals all through the body, as I will come to, working on many negative and positive feedback loops. And so it seems that if you really want to replace heart, it seems very, very difficult, although something which is a credible aim for medical science, to try to replace heart by a machine but although none of the machine has been powered by oxygen and basically metabolizing sugar and not electricity. So still, we know that there are a lot of differences. So coming to the, sorry.
We will have questions at the end.
Pacemaker is its ability, the differences between the plastic heart and an organic heart. So most of the differences lie in the domain of physics, and I will come to them one by one: conceptual, size, longevity, structure, etc. But there are some other differences, and as Madam told us that we cannot equate a living organ just with science. There is a lot of literature, there is emotion, there are non-linear components of the cardiac structure and function of the heart itself, and I will allude to that, which is not possible by any kind of machine which can replace it. So coming to philosophical difference or conceptual difference, we already discussed that any living organism is a matter working on energy organized by informatics. In heart's case, there are very small organelles or cells coming even to nano level and organized by ATP, which is the energy generated by mitochondria, and then information is something which we really don't know as yet. Part of it we know, but like so many other things, it's a very intelligent machine, maybe a divine kind of information that is keeping it going on, and that information we as of now also do not completely understand how that information is coming and how it is going. Maybe it is, you can compare it with godly information where a lot of things in nature happen and we don't understand why it happens. Same thing happens with the heart. It's a machine where the informatics is not known. If you look at a plastic organ that replaces it, you know that it is replaced by either some metal or it may be replaced by a prosthetic material. Energy comes from the battery that we have to give it, and information is not much, that just battery keeps moving. It does not have enough negative or positive feedback mechanism. So really, conceptually any machine cannot replace heart, and I will come to that because it cannot be organized in the same manner as heart has been. Now coming to various hearts that are available, we have something called total artificial heart pump. We have these biomed hearts and we have syncardia hearts. These are the kind of hearts. But I think let me come to the main problem, that the limitations of all these are, one is size. As I discussed, heart is organized at a nano level. The machine is organized at a meter or you can say centimeter level. So how can something which is organized in a centimeter level compete with something which is functioning at a nano level? Second important thing, there is a material fatigue for any material that you use, whether you use a plastic material, whether you use a prosthetic material, whether you use a metal, everything undergoes shear stress and strain and ultimately undergoes fatigue and dies out. What happens to the heart? Heart can not only some part of it can get regenerated because there are cardiac stem cells, but lot of it can get reassigned. So heart muscles can get so part of heart dies because of heart attack, other part of heart will take over its function. So it gets reassigned. So cells may regenerate or redistribute. So that is dynamic possibility is there with the heart. And finally, I think informatics, as I already discussed, the informatics of plastic heart or artificial heart is very simple. It's a computer that you see, but for human heart, that informatics is very, very complex, and I will try to cover part of it, but most of it is still not known. So we really cannot replace it in that level. Now coming to the problems, as I said, size is the first problem that we face. Heart, is a fish-shaped thing which is placed in the little bit left side of the chest. If you replace it with total artificial heart, the least that we are able to achieve is something which is called a TAH, which still requires a larger body surface area. So you don't have enough place for that artificial heart to be placed inside your chest. So what you require is you place something inside the chest, something coming out of the chest. So you may have a battery which is outside the chest, and you have another computer trying to control it also outside the chest. So a single small structure cannot fit in. If you try to reduce the structure, two things will happen. Number one, it will not give enough output, so it will not be enough for the body. Second problem that can happen is that it will have a very short lifespan. So these two problems will start coming in. Second important thing, as I said, is that would be a coordination problem, because the heart is coordinated with not only the nervous system but also the total blood volume. So it can sense what is the total blood volume in the heart, and according to stretch, if the stretch is more, so if blood coming to heart is more, it will automatically think that okay, more blood is coming, I have to push more, so it will contract more. If blood volume is increased, it will produce a hormone which is called anti-natriuretic peptide, which will actually pass off more urine. So heart itself can control the blood volume and pass more urine. No artificial heart is able to do that particular kind of function, to act in this particular coordinated manner, and also understand that heart is functioning at a nano level. Coming to the mechanism of action, you know the mechanism of action of any pump. It could be a centrifugal pump. There are now more advanced pumps also. But heart, if you see, is a pump, is not a pump. It has got a very action like sliding mechanism through which it contracts and it relaxes. And I have shown you on the left side, you can see, and the actin myosin filaments move over each other, and that aids the part of contraction, and then that contraction can happen according to requirement. This machine will give a fixed output, it will give 5 liter, but heart will not be a fixed output, it will be according to requirement of the body, and then cells themselves can adjust the requirement. So it is a far sophisticated mechanism than a mere machine. Now coming to efficiency of the machine, as you can see, it is dependent on three things, again size, the longevity and the coordination. The heart, a normal heart beats 3 billion times in an average lifespan, pumping about 250 million liters of blood in 70 years or so of age. None of the machine can do this kind of work as of now. Maximum the machines are able to work for 5 years. So 70 years versus 5 years, and that too a very large machine, and that too not a very coordinated machine. So it is not comparable. The energetics, the function and bioinformatics of heart, the natural heart is far superior to a machine heart. Very important thing, another thing, I don't know if most of you know that the output of right side of the heart, which goes to the lung, is lesser than output of the left side of the heart. Now if you put a machine will give a constant output, whether it is left side or right side, it will give the same output. So ultimately what will happen is there will be pooling of blood on the right side of the heart, development of pulmonary edema, development of edema all over the body if you just replace the heart by a simple machine. So because of this complex pulmonary systemic balance which heart is able to manage, but a normal machine would not be able to manage, and therefore when we have this problem of heart failing and we want to replace it with a ventricular assist device, then this problem comes in again and again, and we have to put another device on the right side of the heart to overcome this problem. So you require two devices for one heart in these situations. Now if efficiency is less, naturally safety will be less. So there is more chance of developing infection, thrombosis, hemorrhage and device malfunction. As a matter of fact, these are the kind of complications that happen with a ventricular assist device, which is a let us say metallic heart, versus TAH, total artificial heart, which is a plastic heart. But still you can see that there is lot of chances, 20%, 30%, 1/3 risk of bleeding and reoperation, kidney failure about 1/4 of the patients developing, infection and so on and so forth. So list of complications happen when you replace the normal heart with a plastic heart, and infections is one of them. And why infections? Because as you can see, heart sits in one place, But if you put a machine, then there are a lot of tubes coming out, because you need a tube to come out to put up a battery or a pacemaker to make the heart beat. You require a tube to connect to the computer that will control the heart, and so on and so forth. So a lot of tubes are coming out all over the place, and there are higher risk of infection because of these tubes. Second thing, this heart, the human heart, is smoothly lined by endothelial cells, which are the cells of the body. But the artificial heart is lined by plastic or something else, which is not as smooth as the human endothelial cells, and so there is more risk of this let us say friction kind of thing happening, more chances of developing thrombosis or blood clots forming on the heart. So to prevent the blood clots forming, you give them some drugs to make these clots dissolve, but once you give these drugs, there is more risk of bleeding. So not only there is more chance of clot formation, but because of the drugs you give to prevent the clot formation, there will be more risk of bleeding. So one way or other, aage kuan piche khai sort of thing, where you give this, then thrombosis happens. If you don't, then bleeding happens. So something like that. So this is what happens. And then naturally, artificial hearts don't work as good as a normal heart, and they would fatigue. Electrical battery would fail. There will be a mechanical wear of the valves of these, because they are not like those kind of valves, and therefore longevity is definitely affected, and there are higher chances of device malfunctions, mechanical wear of the valves. As I said, they cannot replace the human valves as of now. They are larger and they cause more friction, and they are liable to wear and tear of a muscle. And of course, as I said, you have a battery. All of us know that batteries get depleted. If you implant a heart which has got a battery inside it, that will deplete much earlier. If you have battery that is coming from outside giving supply to the heart, then you have these very big thing. Person cannot move around. He has to be bedridden all his life till that heart is there in place. So you cannot replace clearly organic heart with simply one plastic heart. But more importantly, I think the biofeedback or bioinformatics is the most important part. As I said, heart has got stretch receptors. When there is more blood, the heart muscles stretch. When they stretch, they release this hormone, anti-natriuretic factor, which actually causes the urine to pass more urine, and therefore blood volume decrease, and therefore this stress decreases. So whenever there is a fluid overload in the body, heart will start acting. Second important thing, there is a nervous control. We know that brain can control heart by this nervous system, and there is a hormonal control as well. The kidneys through renin-angiotensin system can affect the heart. So biofeedback is a very important thing. And finally, I think cost. Although human heart is priceless, but if you replace it with an artificial heart, there will be a lot of cost. So I think these are the scientific parts or the linear parts. Now I will try to come into other parts which no machine can do. So we know that heart is the location of this heart chakra that we talk of in yoga and other kind of Eastern philosophies, and it is associated with a lot of things, love, reality, etc. My attempt is to show you what is the science, if there is any science, behind these non-physical aspects of the heart, and I will try to tell you. So this is something, an interesting concept called heart rate variability. Heart rate variability, if you see, this is the heart rate, ECG, but ECG does not remain regular. There is very important thing, there is an optimal level of variability in the heart rate, which increases with changes with respiration and changes with other things. So this variability is very important. If this variability is lost, then actually there is a risk of dying, and when we check a person is going to die very soon, we check for heart rate variability. If this heart rate variability is lost, we know that this person is at risk of dying pretty soon. And this variability is also dependent on the sympathetic and parasympathetic nervous system, and that determines the variability, and therefore we can actually, knowing at this particular factor, we can predict whether this person is going to live long or he could die early or so on. But did you know that this variability is also reflective of the emotion? So once somebody is frustrated, you can see the variability decreases. So on the left side you can see, once the person is frustrated, anger, Other bad emotions, variability decreases, which means that there is a risk of person actually dying. On the other hand, when there is appreciation and good emotions, the variability increases. And so positive emotions lead to increase in variability. So heart could be considered as a seat of emotion as well, and as reflected by the variability. Scientifically we see this variability, and this is a scientific concept. It is not a, some metaphysical concept. And in literature on and on we see that heart is being talked about as a seat of emotion, and just pertain to that, even in Western metaphysics, heart has been considered a wormhole or a gateway from where the spiritual and physical experience meet. So this is not only exclusive to Eastern philosophy, but what I will do is, and even in Sufi philosophy, that heart has been considered as the seat of soul, even in Sufism, and we are not talking of Hinduism at the moment. But coming to Hinduism, actually, as a matter of fact, there are 5 dimensions to heart, and that has been discussed in some of these Hindu philosophies, and I just touch upon them because I thought it was interesting, and since it had to deal with heart. One is the physical body. Of course, we know about the physical body, which is the pump, but that is not all. It is, somebody was discussing where is mind, where is consciousness. There are some, if you read at scriptures, you will find that this mind is not located in brain. Brain is just electrical circuit. And as somebody also told us, that the decision is taken earlier. But if you measure only the brain waves, the decision is already taken, the brain wave comes later. That is because the decision is probably happening at somebody else. Now let us propose, if you look at heart rate variability, maybe you can realize that decision happened through heart and was communicated to brain, and then brain, actually conveyed this particular thing. So there is a belief that man stays in heart, then the breath body, the automatic part of the body, that is the automatic respiration, automatic heartbeats, and even automatic brain functions are probably linked to the heart area. Then coming to the intelligence body, we have 3 types of intelligences, which also some Hindu scriptures say are seated in the heart area. And then finally the final body, that is the soul, also located within the heart. Atma and Paramatma also located in the region of the heart. So this is the mind realm, we know that, but I think, is there any science? Can we say that this, we say that mind is located in the heart region? Is there any science about it? So again we come to, the nervous system of the heart. And while all of us know that heart is connected to central nervous system, and brain, we think, at least part of the brain controls the heart. But did you know that 85 to 90% of the nerves are actually efferent nerves, which means that 90% of the nerve supply is coming from the heart and going to brain, and only 10% coming from brain and going to heart. So heart is controlling the brain and not vice versa, or at least 90% of the nerves are going from heart to brain. They are the afferent nerves, versus only 10 to 15% which are the efferent nerves. And I think that is a very important aspect, and I think that is why the heart can be considered as the central coordinating organism of whole over the body. And what about the comparison? Why do we say that one thing is that the nerves are going from the heart into the brain, and therefore heart is controlling brain? Second important thing, if you look, there are these 3 types of breathing. Breathing is also another automatic system, and I will show you one very interesting study. If you look at the breathing and you compare it with heart rate variability, so if there is a normal breathing, we have a normal heart rate variability. But when there is a focused breathing, then we see that amplitude I will show you here that the amplitude of the heart rate variability increases and heart rate variability decreases. So once there is a synchronization of the heart, when we have focused breathing in pranayam, we know that we have focused breathing. We look at how we take in breath, how we expire breath, and once we do that, we realize that the heart rate variability actually decreases, which shows that breathing and heart rate is also linked. And not only linked, there is increase in amplitude, which shows that heart is synchronous with other processes that are going all over the body, including the brain waves, including other digestive kind of milieu, even excretory milieu, all of them get synchronized when heart rate gets synchronized with all these systems. So possible that heart rate is the basic synchronizer of all the rhythms all over the body, including the brain wave. Okay, 5 minutes, I'll finish before that, sure. And I will, now coming to this last, some of the later aspects, we know that there are, 3 types of intelligence, which we call Brahma, Vishnu, Mahesh, which I think in Western philosophy they call good, bad and the ugly. And let us not go into that, but these are the 3 aspects of intelligences. So one is good, which is Brahma, other is bad, which is death, so maybe Shiva. Don't take it on that. But ugly is the one which is more practical. So if you remember that movie, if some of you saw, madam must have seen, I'm sure, in that movie, that was the most practical person. He could, use good or bad according to circumstance, and that is what is Krishna. He can use good or bad according to requirement and then move accordingly. So this is what happens, once there, and it is believed that this center of intelligence that we consider is also located in the region of the heart. And finally, I think the 5th dimension that we all of us think that we should be heading to, and that dimension we all of us know, at least in Hindu scriptures it is said, it is that gufa which is located in the heart, from where the soul migrates and goes to the antariksh. So I think this is the essence of what I was trying to say. So finally I'd like to conclude that structurally plastic heart, as far as I've tried to convince you, is much inferior to the organic heart, not only in terms of matter and energetics, but also in the organization of the information. The inefficiencies exist in terms of size. If you want to replace heart, you require a huge size of a plastic body to replace it. In terms of coordination, you require a lot of coordination, which is not possible, but also the longevity is affected. So I think they want me to end, so anyway, this is the last slide. But as I said, heart is more than a mere structure. It encompasses not only science, but arts, literature and spirituality. So thank you very, very much for a patient hearing.
Thank you, Dr. Mishra ji, for a wonderful explanation and